Kia ora. Here are 3 flash animations that are quite useful in helping you to explore and reinforce your ideas on buffer solutions. So the first one is fairly simple. You are given water, a solution of sodium chloride, which is not buffered, and then a buffered ethanoic acid that's buffered together with its conjugate ethanoate base. And so what you can do is you can add HCl to each one, and notice that there is a big change for the unbuffered systems, but only a small change for the buffered system. Or if I add sodium hydroxide, then I'm just adding it twice. You'll notice there's a big change for the unbuffered, but if I add it to the buffered system, then there is not much of a pH change. With preparing the buffer solution interactive, here what you need to look at is the target pH. So you need to make up a buffer that's 3.68. And so what you would do is you would look for the pKa values that are closest, and the 3.74 is the closest to this. So then you would say, okay, the way I have it set up here is 3.74, which is slightly more basic than 3.68. So I need to add a little bit more acid to bring down the pH. So I would change my concentration of the acid until I got my target value. Sometimes it doesn't work exactly on target. So you then click New Target to see what the next buffer system you can use. So for instance, this is 8.04, so you would see which one is closest, and here it is the borate one, which is 7.6. And now, again, we've got to bring down the buffer. Because that's about the closest, because that's more than a pH unit out. So for instance, here we need to again increase the acid to bring it down to the required pH. Now notice there's quite a big change in your buffer system here, so this is not ideal, simply because the bigger the difference in the concentration of your acid and base, the less efficient the buffer system it is. So in other words, it can't absorb both acid and base. It can only start absorbing one, and then eventually it does not work anymore if there's too big a difference. So if I, for instance, try another target, you can see it's 3.75, so it's nearly bang on for that one. Whoops, there. And now we just change this, remove the acid, and we could perhaps increase the base. Now, notice that if I keep to the same concentration of acid and base, same ratio, then it doesn't matter. As long as I keep to the same ratio, I will always have the same pH. So, for instance, this is 3.77. If I make that 0.2, 3.74. If I now made this a lot more, but I kept it to the same concentration ratio, then it's still 3.74. So the ratio is the important bit for what the pH would be. So explore different targets and so on. The final one is the pH of buffer solutions. So this is what you can use to practice your Henderson-Hasselbalch buffer equations and calculations. So you can either use the concentration of the acid with its conjugate base and say the pH to work out the pKa, or you could use the concentrations and the Ka to work out the pH. So for example, if I had this concentration and I then try to calculate the pH, you can see straight away whether your calculation is correct. Did you get 9.31? Or you might try something else and say, okay, I'm going to use a pKa and a pH, and I'm going to use the concentration of my hypochlorous acid, and I want to see if I can work out the concentration of my base, or the conjugate base. So just keep on practicing here again and again, so you can keep on checking to see if you can use that equation. So have fun exploring and calculating. Kia ora.